let's talk about one of the most common and, frankly, one of the weirdest elements on the entire planet. An element that's somehow both the sparkly prize on a ring and the simple gray tip of a pencil. Yep, we are talking about carbon.
Okay, so here's a real puzzle for you. How can the exact same element, the same basic stuff, create something so incredibly hard it can cut through steel, and at the same time create something so soft it just crumbles onto a piece of paper? I mean, it sounds totally impossible, right? Well, welcome to the paradox of carbon. I mean, really think about it for a second. On one hand, you've got diamond. It's see-through, it's brilliant, and it's so tough we use it to drill through solid rock. And on the other hand, you've got graphite. You know, the lead in your pencil? It's dark, it's dull, and it's so soft that it literally leaves a trail of itself behind every time you write. They're polar opposites, but they're made of the exact same thing. So, how in the world do we solve this carbon paradox? Well, the answer is pretty cool, and it all comes down to going back to the absolute basics and figuring out what carbon actually is. You see, at its heart, carbon is actually super simple. It's an element, which just means it's a pure substance made of only one kind of atom. It's not a metal, and, well, it's solid at room temperature. That's pretty much it. Every single form of carbon, from the priciest diamond to the cheapest pencil, is built from the exact same atomic Lego brick. So, if they're all made from the same tiny building block, why the huge difference in what they can do? Well, think of it this way. If the ingredient is always the same, the recipe has to be different. And that right there is the whole secret. It's not about the atom itself, but about how those atoms are put together. The pattern they form, their atomic blueprint, that changes everything. All right, so let's put on our atomic architect hats for a minute. These different forms of the same element, they have a cool name. They're called allotropes, and we're going to look at the blueprints for carbon's most famous allotropes to see why their arrangement really is everything.
First up, the famous one, diamond. The best way to think about its structure is like an atomic fortress. It is designed from the ground up for maximum strength.
So inside a diamond, every single carbon atom is locked down tight, bonded to 4 other atoms around it. This creates this perfect, super rigid 3D grid or lattice. There's just no wiggle room. At all. This structure is basically the definition of strength, because if nothing can move, nothing can be easily broken. Okay, now let's look at graphite. If a diamond is an atomic fortress, graphite, well, it's more like a deck of cards. It's all about the layers. And here, it's a completely different story. In graphite, the carbon atoms arrange themselves into these flat sheets. Now, the bonds inside each sheet are really strong, but the bonds between the different sheets, super weak. This means the layers can just slide right over one another. That's why graphite is slippery, and it's why it leaves a mark when you write. You're literally scraping off layers of carbon atoms onto the page.
You know, this whole layer thing leads to a really interesting question. We know the sheets themselves are actually incredibly strong. So, what do you think would happen if you could just peel off one single atom-thin layer?
Well, if you did that, you would get this, graphene. It's a form of carbon that was only really discovered back in 2004, and it is nothing less than a real-life supermaterial.
And when I say super, I am not kidding around. Get this, a single sheet of it, just 1 atom thick, is 300 times stronger than steel. It's actually even harder than diamond. It's unbelievable.
The potential here is just enormous, and scientists are really just getting started. I mean, graphene could completely change the game for everything from sportswear that's both flexible and strong, to super advanced medical devices, to electronics that are lighter and more powerful than anything we have today.
Okay, so from the far-out potential of a perfect 2D sheet, let's bring it back to how we're already putting carbon's amazing properties to work right now, often by mixing it with other things to build incredibly strong, lightweight stuff. And a perfect example of this is in high-performance sports. As Paralympians, like Great Britain's Steph Reed, know well, the unique properties of carbon are exactly what make modern running blades possible. They give you that amazing combination of strength and lightness that almost no other material can match. This is all done using carbon fibers, and they're pretty much what they sound like. They're long, incredibly thin strands made of carbon atoms. Their special magic is that they are extremely strong and stiff, but they weigh almost nothing.
The process for making this stuff is actually pretty clever. First, you create these long, thin strands of carbon. Then, you take bundles of these fibers and weave them together into a kind of fabric. And finally, you bake that fabric with a plastic resin,
which hardens up and locks it all together into a super strong, super light material that's perfect for everything from race cars to airplanes.
But as incredible as all of that is, carbon's story doesn't end with technology and materials. In fact, its most important role is way more personal. It's the role it plays inside every single one of us. Just let this sink in for a moment. About 20% of your body, by weight, is carbon. After oxygen, it is the most common element inside you. It is, quite literally, a huge piece of who you are. And that's because carbon is the essential building block for all life as we know it. Its unique ability to form strong, stable bonds with lots of other elements makes it the perfect atomic backbone for all the complex molecules that life needs to exist. Now, just to be clear, this doesn't mean you have tiny bits of graphite or diamond floating around inside you. No, the carbon in our bodies is joined up with other elements like hydrogen and oxygen, and together they form this huge variety of compounds that build our cells, our tissues, everything that makes us, well, us. So, from the soft tip of a pencil to the hardest diamond, from the running blades of a world-class athlete to the very DNA that defines who you are, carbon is there. It's both the most essential building block for life and a futuristic supermaterial. Which really just leaves us with one final fascinating thought. What on earth will we build with it next?